How does all in Python work on empty lists? I am referring to the following Python code. I expect the above code to return true if all the elements in my underscore list are 2. But when I make my underscore list empty and run it as, it returns true as well. I am confused with this behavior. Is it not supposed to return false as there is no element in my underscore list with value 2?
It's true because for every element in the list, all 0 of them, they all are equal to 2. You can think of all being implemented as, whereas any is. That is to say, all is innocent until proven guilty, and any is guilty until proven innocent.
All applied to an empty list is vacuously true, as is easily confirmed. Similarly, if 0 equals 1 then the moon is square is true. More generally, all p are q. If there are no p's then the statement is considered true, as it can be captured formally as for all x. If x is p then x is q. Ultimately, these are true because the conditional logical operator, if then, evaluates to true whenever the antecedent, the first clause, is false. If false then true evaluates to true. Recall that if a then b is equivalent to, not a, or b. Added 1 to 2022. In the case of all and Python lists, the Boolean value of all my underscore list is the value of when my underscore list is empty, that value is true. Again, for all and all make no existence claim. In Python pseudocode, all works roughly like this.
Consider a recursive definition of all. If every element in L is true, then it must be true that both the first item in L is true, and that all L1 column is true. This is easy to see for a list with several items, but what about a list with one item? Clearly, every item is true if the only item is true, but how does our recursive formulation work in that case? Defining all to be true makes the algorithm work. Another way to look at it is that for any list L for which all L is not true, we should be able to identify at least one element, A, which is not true. However, there is no such A in L when L is empty, so we are justified in saying that all is true. The same arguments work for any. If any L is true, we should be able to identify at least one element in L that is true. But since we cannot for an empty list L, we can say that any is false. A recursive implementation of any backs this up. If L0 is true, we can return true without ever making the recursive call, so assume L0 is false. The only way we ever reach the base case is if no element of L is true, so we must return false if we reach it. The reason why is already well explained by other answers. As a quick fix you can use